Hello again. We're continuing the questions for the Math 104 Gateway. We're on number 47 from the pool 44 through 53. And we want to solve for x in the equation 2 times x to the fourth minus 13 times x squared plus 15 equals 0. So, noting that we can express x to the fourth like so, x squared times x squared, which can also be written as x squared squared. We can use u substitution by letting u equal x squared, which will then give us the following expression. We'll get 2u squared minus 13u plus 15 equals 0. So we're left with a quadratic equation, so we can use our quadratic formula by letting 2 be our a term, 13 be our b term, and 15 be our c term, which will then give us the following expression for u. Okay, u equals b squared, so or negative b, excuse me, which is 13, plus or minus the square root of b squared, so that's negative 13 squared, minus 4 times a times c, which is 4 times 2 times 15. And that is, of course, all over 2 times a, which is 2 times 2. So we can simplify this a little bit, and we will get 13 plus or minus negative 13 squared, which is 169, minus 4 times 2 times 15, which is 120. And that, of course, is all over 2 times 2, which is 4. So we can simplify this a little further, and we will get 13 plus or minus, that's the square root of 49, all over 4. And then simplifying once more, we will get 13 plus or minus the square root of 49, which is 7 over 4. Now this gives us two values for u, so we get u equals, that's 13 minus 7, that is 5 over, no, excuse me, that is 6 over 4, which is of course 3/2. And then we get u equals, that's 13 plus 7, that's 20 over 4, which is, of course, 5, just 5. Now with these two values of u, we can substitute, or rather we can undo the u substitution. So we then get 5 equals x squared, and then 3/2 equals x squared. This then gives us our solutions of x equals plus or minus the square root of 5, and then x equals plus or minus the square root of 3/2. And since we just used u substitution with the quadratic formula, we know that these are valid expressions for x, and that these are in fact all of our solutions.